Welcome to Maths for You channel. Past paper question on differentiation. Question: a curve has the equation y equal gx given that gx is a cubic expression. So we'll stop it there and then establish where we are going. So question 1, y equal gx. Gx is a cubic function. So y equal gx is a cubic function. Typical cubic function is ax cubed plus bx squared plus cx plus d. A, b, c, d are constants. Or coefficients of x cubed, x squared, x, and x to the power 0. Let's read the first line, second part of the first line. The coefficient of x cubed is equal to coefficient of x. That means from that y equal equation or curves equation, the coefficient of x cubed equal to coefficient of x. Therefore, a equal c. So now we can rewrite that y equal gx, that is equal ax cubed plus bx squared plus ax, because it's a equals c, plus d. So c out of the loop. Right, now we have the equation of the curve, the cubic expression of the equation. The second line of information: the curve with the equation y equal gx passes through origin. Just say if it's a curve, it's actually passes through origin. So if it passes through origin, the coordinate of origin, which is 0, 0, should satisfy the equation. So therefore equal y equals 0. So a x to the power of this, that is 0, plus b times 0 plus a times 0 plus d. Therefore d equal 0. Now the equation is getting simplified. So gx equal, you'll rewrite it, a x cubed plus bx squared plus ax, d is 0. So now just we're down to only two constant a and b. Then that will actually give us equation of the curve, or y equal function. Right, second line done. Third one, the curve with equation y equal gx has a stationary point at 2 and minus 10. Say a stationary point. Stationary points mean either stationary point or turning points. At stationary point and turning point, the gradient of the tangent line would be 0. The gradient of the tangent line, or gradient of the curve, is dy over dx. So before we go further, let's differentiate. Dy over dx equal a times 3x squared plus b times 2x plus a. This is going to be 3ax squared plus 2bx plus a. So the differentiation of y is this. The differentiation of y is the gradient. The gradient is at turning point. At gradient at turning point would be 0, because of tangent line at gradient at turning point will be parallel to x-axis. So at the turning point, at turning point, say it could take here, that is 2 minus 10. Right, at 2 minus 10, I'll write that, at 2 minus 10, 10, say it's P or whatever, and that is the turning point. Therefore, dy over dx equal 0 at turning point. Point dy over dx, which is gradient, equals 0. Dy over dx, we know that 3ax squared plus 2bx plus a. That is the gradient. But we know x value of that at that particular point, x value is 2. X value is equal to, at the same time, that is 0. So x value 2. So 3a times 2 squared plus 2b times 2 plus a equals 0. This is going to be 12a plus 4b plus a equals 0. If you could simplify it further, 12a, 13a plus 4b equals 0. That's one equation in terms of a and b. Has a stationary point. At the same time, the stationary point or stationary point 2 minus 10 is on the curve as well. Therefore, that coordinates 2 and 10 will satisfy y equal the curve equation. So y equal ax cube plus bx squared plus ax. This will, so 2 minus 10 will satisfy because of this point is on the curve. Therefore, minus 10 equal a times 2 cube plus b times 2 squared plus a times 2. So minus 10 equal 2 to the cube is 8a plus 4b plus 2a. So if we could simplify it and rearrange it, 8 plus 2 is 10a plus 4b, that is equal minus 10. So another equation in terms of a and b. So if you look at equation 1, equation 2, if we could subtract 1 from, subtract 2 from 1, it will be 13, that is 3a, 4b cancelled out, and 10 become positive. So 3a, so a equal 10 divided by 3. Having found a equal 10 over 3, it could use any equation. So first equation, say if you look at 13a plus 4b equals 0. A, we know that. So 13 times 10 divided by 3 plus 4b equals 0. So 4b equal 13 times 10 is 130. If we take to the other side, minus 130 over 3. So b equal minus 130 divided by 4 times 3. So if we could common to common, so that will be 2, that's 65. So it will be minus 65 divided by 6. So b equal minus 65 over 6. A equal 10 over 3. Let's go to that equation. The equation is ax cubed plus bx squared plus ax. So if we could substitute these constant values a and b onto here, the 10 over 3 times x cubed plus minus 65 over 6 x squared plus 10 over 3 times x. So this is going to be 10 over 3 x cubed minus 65 over 6 x squared plus 10 over 3 x. This is the equation of the curve. That's the first question. Yes, find gx. So that is gx. So first part done. Let's look at the second part. Prove that the stationary point at 2, 10 is a maximum. So we know that 2 minus 10 is the stationary point. So that stationary point to minus 10. What we have to prove is the maximum. So if it's a stationary point, minimum, stationary point, there can be maximum, minimum, or point of inflection. So here, maximum. So let's see, in order to find that either maximum or minimum or whatever, we need to go into the second order differentiation. So we know dy over dx equal we found dy over dx, that is 3x squared, 3ax squared. I'll write it again, 3ax squared plus 3x squared 2bxa plus a. We know these values, so 3 times 10 over 3 x squared minus 2 or plus 2 times minus 65 over 6 x plus 10 over 3. Let's simplify a bit further. 30 divided by, 3 cancelled out. So that will be 10 x squared minus, so this is 3, so minus 65 over 3x plus 10 over 3. That is dy over dx. Let's differentiate again in order to find the in order to decide maximum minimum, that turning point maximum minimum. d2y over dx squared equal, this will be 20x minus 65 over 3. But at the turning point, x equal 2. So we can substitute that, d2y by dx squared when x equal 2. That would be 40 minus 65 over 3. This is positive. If it's positive, if the second order is positive, the turning point is minimum. That is exactly what we been asked to prove. Thank you.